Good morning, everybody. I'm very excited to be here today to talk about high throughput computing workloads with HTCondor. Here we go. Specifically, today we'll be learning how to organize and submit workloads composed of many jobs using HTCondor. We'll discuss how to know which files to consider when organizing your high throughput computing workloads. We'll discuss how to plan and implement an organizational structure for your files on the access point that you're working with, and how to utilize different HTCondor submit file options to accommodate your organizational structure and data movement strategy. So let's start out by thinking about our workload components. High throughput computing, as Christina mentioned earlier this morning, is the approach to solving a big problem by executing many small, self-contained tasks and joining them together in the end. One of our favorite examples of this is baking the world's largest or longest cake. The high throughput approach to solving this problem would be to make many small cakes and to assemble them together in the end to make one large product. What's not pictured is how the bakers would organize all of the inputs, in their case ingredients, and their outputs, which would be individual cakes, before they were joined together. That's what we're going to be focusing on today. Specifically, today we're going to be thinking about workloads that use many input files to produce many output files. Why do we want to organize our workspace? That's the first question we want to start with. So by default, HTCondor writes all job files, including the inputs, outputs, HTCondor logs, etc., back to the same place, which means that your workspace can look something like this, which is very cluttered. It's difficult to find things. It can really slow your analysis down as you're trying to remember which files correspond to which job submissions, etc. We can improve our workflow by creating a much cleaner, organized workspace where our input files are in one folder perhaps and our output files are in a different folder. So over on the right, we have an example of a much cleaner workspace with clearly named directories that can tell us what's inside those folders. So for example, we have an error folder, which likely contains our standard error files. We have an input directory, which likely contains our input files for our jobs, so on and so forth. So the example that we're going to be working with today is a text analysis example. We will have a book text that we will be analyzing. We will use that book as input for a Python script that counts the the frequency of different words within that book, and then we'll output those values in a text file. So normally when we would run this on our own, perhaps local computer, we would execute it by typing something such as period / the name of our executable, which today will be wordcount.py, followed by the argument for that executable, which starting out today, we will be analyzing the book Dracula, which is saved in a text file called dracula.txt. So today we'll first learn how to create a clean workflow and organized workspace for one analysis, and then we'll scale up our analysis while also keeping a clean workspace. The organizational setup for our files today, we'll start out and we'll have a submit file called books.submit. We will also have our Python script, which is called wordcount.py. And then we're going to assume that we want to have all of our input files, which are our books, within an input folder. And then we're going to also assume that we want all of our output files within a separate folder, which will store all of our counts for each text that we'll be analyzing. The one thing that we want to keep in mind, though, is that there will be additional files automatically produced by our job. And those are the HTCondor log, standard error, and standard out files. So we also want to keep these organized. We're going to be storing our log file within a log directory. And then we're also going to be storing our standard error and standard out files automatically within an error out directory. So this is the organizational setup that we're going to be working with. So let's go ahead and think about organizing and submitting one job. Before we jump into that, just a quick refresh of some important shell tools that we'll be using. mkdir stands for make directory, if you want to make a folder to store files in. mv stands for move. It can be used to move a file into a different destination. And then we'll also be using wildcards. So specifically, we'll be using this asterisk wildcard. So here the command that we'll be using is ls, which stands for list, space, and then the asterisk followed by .txt will match all files ending with the .txt extension. So here this command says list all files ending in .txt. The submit file options that we'll be discussing today will be transfer output remaps. Transfer output remaps is a really great option. It's used to save output files to a specific path using a certain name. So this is a great feature if you would like to save output files to a specific folder, and if you want to rename your file to avoid rewriting over existing files. We'll also discuss initial dir, which sets the submission directory for each job. When you set this, it becomes the base path where output files will be saved to. This is a really great option for individuals who want to submit multiple jobs from different directories, or if you want to avoid having to write some paths and other submit file values. And we'll discuss a few other reasons why you might want to use initial dir. So to start out, we will be doing a live demo. If you would like to follow along, please log into your HTCondor access point. If you would prefer to listen, these slides are available, as well as a recording of this talk will be available later today. So what we'll do is we'll all log into our HTCondor access point. We're then going to be downloading some files using this command. We'll explore the files that we've then downloaded, and we'll begin organizing our workspace before we even think about submitting our first jobs. So I've gone ahead and have already logged into my access point. Here we go. So I've gone ahead and I have already logged in. I personally log in with an SSH login protocol. You may log in with a different form of authentication.
Rach,
yes.
It's getting cut off on the screen up there. Ooh. If you could kind of hit enter a couple times.
Yes.
At least until we figure out how to move that down. Thank you very much.
Thank you. So once you log in, if you'd like to download the files, the command is git, spelled G-I-T, clone, and then the HTTP address that we will be downloading today is https://github.com/organizing-examples. Once you've typed that, you can go ahead and hit enter. You should have some output like this. And if we go ahead and type ls to list the contents of our directory, we see that we've now successfully downloaded a folder called Organizing Examples. Now let's go ahead and navigate inside of this directory by typing cd and then the name of the folder. Oops. And if I type ls to list the contents, we see that we have some folders already created for us, our input directory, a log directory, output, and error out. We see over here in green, we have our word count.py script. Up here on the left, we have our submit file, and then we have various texts that we'll be analyzing today. So we'll be starting out with Dracula, but then we'll scale up our analysis to analyze other texts, such as Alice in Wonderland, Huckleberry Finn, and Pride and Prejudice. So the first thing that we want to do before we submit any jobs is organize the workspace that we already have. To do this, we want to move all of our input files into our input folder. So to do that, we'll type mv for move. And then we'll use our wildcard asterisk followed by .txt. And then so we're going to move all files ending with the .txt extension into our input folder. When we're ready, we can hit enter. If we type ls again, we see that we no longer have our text our books within this location in this workspace. So we're going to go ahead and then look inside our input folder. So if we list the contents of the input folder, we see that we successfully moved our books to that location. So now that we have a clean space starting out, let's go ahead and think about how we're going to begin editing, or excuse me, before we think about our submit file, let's think about the workspace that we want to create. So over on the left, before we submit any jobs, this is the workspace that we're working with. We have our submit file, our Python script, our input text files are within our input folder, and our remaining directories are empty. After we submit a job, what we want HTCondor to do automatically for us is store our output count files within an output folder, store our log files within our log folder, and to automatically save our standard error and standard out files to this error out directory. So let's go ahead and start our editing our submit file to do this for us. So to start out, I like to begin with entering the values for the executable and arguments for the job. So our executable is that word count.py script. Our argument is Dracula.txt. Then, let us transfer our input files. So this workflow assumes that we need to specify that we need to transfer these files. The file that we need for this job is Dracula.txt, but we need to tell HTCondor where to find this file. This file is now located within the input directory. So we want to specify that path so that HTCondor knows exactly where to look to find Dracula. Then we're going to use our transfer output remaps option. The syntax for this is to begin and end with a quotation mark. It's very important to not forget those. The initial value is the name of the file that your analysis creates. So the name of the file that your script creates, which in our example is count.dracula.txt. And then you'll set this equal to the path that you want this saved to. So we want this file saved to our output directory. So we'll tell HTCondor to do that. And then lastly, we specify the name that we want this file saved as. So in our case, we're saving it as the same name. If you wanted to, you could replace this text right here with a different name, and HTCondor would automatically rename your file. Lastly, we want to think about those other files that will be produced by our job. So we want to specify that we want our log file saved to our log folder. And the name that we're going to be using for these files is job. And then we're going to call that process ID so that we know which log, error, and output files correspond to which job. And then we'll use our .log extension. Similarly, for the standard error and standard out files, we will be saving them using a similar name ending except with .err and .out. But this time around, we want those files saved to the error out directory. Lastly, we want to make sure that we have our queue statement so that HTCondor knows to queue one job to analyze Dracula.txt. So now that we've done this, let's go ahead and analyze one book. I'm going to jump back to my terminal, type clear just to move my prompt to the top of the screen. And then I'm going to move my prompt down a little bit so that people can hopefully see. There we go. So if I type ls to list my files, I see my books.submit file over on the left. I want to open this file up in my favorite text editor. In my case, my favorite text editor is Nano. So I will type Nano, followed by the name of that file, hit enter, and now we can go ahead and edit this file. So our executable, as we remember, is word count.py. Our argument is Dracula.txt. The transfer input file, as we remember, we want to transfer that Dracula text, but it's now located inside the input folder. So we want to specify that so that HTCondor knows where to look. So it'll be input/Dracula.txt. For our transfer output remaps, really important, we want to remember to start with that quotation mark. Our file name that is created by our script is count.dracula.txt. We want to set that equal to the path that we want to save it to, which we want to save it to our output folder under the same name, just count.dracula.txt. And importantly, ending with that other quotation mark. For a log file, we want to save it to our log folder under the name job. And then we're going to call that process ID variable using $, parentheses, proc ID, close parentheses, with the file extension .log. For standard error file, we want it saved to our error out directory under a very similar name, except for the .err extension. And for our output file, our standard output file, we want it also saved to the the error out directory under job. Calling that process ID variable and ending with the .out extension. So just to recap, we entered in a name of our executable, our argument for this job, which is Dracula.txt. We're transferring the input file Dracula.txt, which is located inside of our input folder. We're using transfer output remaps to automatically save the output file created by this job into an output folder. And then we're saving our log file to a log directory and our standard error and our standard out files to an error out directory. So once we've done this, we can go ahead and type Control X if we're using Nano, Y to save, and then we're going to go ahead and hit enter to save it as the same name. So just to make sure, if we type cat and then the name of our submit file, we see that our changes have been successfully saved. And we could go ahead and submit this job to HTCondor. Yeah.
The output that you're transferring the remap, is that back on the access point or is that on the execute point? Access point?
Yes.
Thank you.
Transferring back to the access point, yes. So if you're done editing this file, you can go ahead and submit your job to Condor by typing condor_submit, followed by the name of that submit file. When we do this, we can hit enter. We see that we've successfully submitted our jobs. And importantly, right now, we've only submitted one job. That's important to note because later we'll submit more using a single submit file. My favorite command to watch my job in the queue is condor_watch_queue. This command provides live feedback from your job in the queue. So we see that we've submitted one job. Currently, my job is idle, waiting to be matched to a spot out on our system to begin running. So while I wait for this job to begin running, I'm going to pop back over. And now that we've successfully submitted one job, let's go ahead and start thinking about how we're going to submit a full workload, which is typically composed of many jobs. When we want to submit a whole workload, the first thing that we often want to think about is how we're going to modify our queue statement. As Christina mentioned earlier this morning, there's many ways to change your queue statement to queue multiple jobs automatically. The syntax that we'll be using today is queue variable from list.txt. We'll create this list.txt, and for each line in this list.txt file, a different job will be queued by HTCondor using those values. So the first thing we want to do is actually create this list.txt file, which will contain the names of the books that we want to analyze. So it should look something like this, where we have Alice in Wonderland on one line, Pride and Prejudice on the next line, Dracula on the next line, so on and so forth. It's important to note that in our example today, this is a list of input files, but this could easily be a list of values such as parameters, if that's more relevant for your workflow. To do this, we'll just want to make sure that if we type pwd, we're inside of our organizing examples folder. And then we're going to use this command, ls input, to list the content of our input directory. We'll use a greater than symbol to save these values to a file called list.txt. Oh, and before we do that, I actually see that my job is done. So I'm going to go ahead and exit this view, which we see down here. You can type Control-C to exit. I'm going to type clear to move my prompt to the top of the screen. And if I type ls, I see that I have no new files in this workspace, which is great because I didn't ask HTCondor to store any files in my current location. Instead, I asked HTCondor, if we navigate to our output directory and list the contents, to save my count.dracula.txt file in this location. And we can actually go ahead and investigate this file by typing tail count.dracula.txt. And what we see are the most frequently reoccurring words within this book. The most frequently reoccurring word is the, which has over 7,000 appearances, followed by and I, so on and so forth. So this is great. Let's go ahead and navigate back up one directory by typing cd ... And while we're here, we can just type ls to list the contents of our error out folder. And we see that HTCondor saved our standard error and standard out files back to this directory, which is also what we expected. And lastly, if we just investigate our log folder, we see our HTCondor log file has been saved there. So that's great. We have one job that's outputting files in the locations that we expect. So let's jump back to thinking about that list.txt file so that we can go ahead and scale up our analysis. I'm going to type clear to move my prompt to the top. And to create that list.txt file, we first want to make sure that we're all in the same location. We want to make sure that we're inside of our organizing examples folder. And then if we type ls input to list the contents of the input directory, followed by the greater than symbol to save this output to a file called list.txt. If we hit enter and ls, we see that we successfully created this file. And then I can type cat, the name of this file, to list the contents of it, in which each of our books is on a single line. So now that we have our list.txt file, we can go ahead and start thinking about the changes that we want to make to our submit file to go from analyzing one job to going to analyzing several jobs using a single submit file. So as I mentioned, my favorite place to start is this Q statement. We went from Q, and now we want to change the syntax to Q variable from list.txt. So I've renamed my variable, which you can do as well, to be Q book from list.txt. The great thing is that now that you have created this variable within your submit file, you can actually use it elsewhere in your submit file, which is what we're going to do. So what we want to think about are replacing any values that will be changing from job to job with variables. In our case, every time that we see Dracula.txt, we want to replace that text by calling the book variable. To do that, every time we see Dracula.txt, we will go ahead and insert $ parentheses book close parentheses, so that HTCondor will automatically change the values to depending on which job is queued. So for example, for the first line of our list.txt file, if the value is Dracula, this variable will be replaced with Dracula.txt. If we're analyzing Alice in Wonderland, these values will be changed to Alice in Wonderland.txt automatically by HTCondor. So let's go ahead and analyze many books now. To do this, I'm going to jump back over to my terminal. I'm going to open up that submit file one more time using Nano. And as I said before, my favorite place to start is always by editing this Q statement down at the bottom. So if I say Q book from list.txt, we've now edited our Q statement, and we can use this book variable in our submit file. So at this point in time, what I tend to do is jump back up to the top and work my way logically down. So every time I see the word Dracula.txt, I want to delete it and replace it by calling that book variable. So I've just edited my arguments line. Now that we've done that, we can jump to our transfer input files line. I see Dracula.txt, and I want to replace that by calling that book variable again. Lastly, for our transfer output remaps line, we're going to delete Dracula.txt and call that book variable. So we want to make sure that we're replacing both appearances of Dracula in this line. So just to recap what the changes that we've made, we've changed our Q statement to be Q book from list.txt. We've edited our argument statement to call that book variable. We're transferring the relevant book files from our input directory, and we're going to be automatically saving the output of each analysis back to our output folder by editing our transfer output remaps line. Once you've done this, we can, if you're using Nano, type Control-X, type Y to save them. And then for simplicity, I'm going to keep this file name the same. However, for your actual workflow, I would recommend renaming the submit file to be something such as manybooks.submit so that you always have your original submit file to go back to. So I'm going to go ahead and hit enter, cat, just to list the contents of this. One more time, we see that our changes have been successfully rendered, which is great. That's what we expect. And then we can submit this job to Condor by typing Condor submit, followed by the name of that submit file. When we hit enter, we see that we've successfully submitted our jobs, which is great. This time around, we see, however, that we have successfully submitted 5 jobs using one submit file. And if we check on our jobs in the queue by using that condor_watch queue command, we see that our previous job may still be in the queue, which we had a total of 1 that's now done. But this time around, we see our new batch ID with a total of 5 jobs, and all 5 jobs are currently idle, waiting to be matched to a slot to begin running. So while we wait for that output, what we would expect to see when our jobs are done is a workspace like this, where we still have our submit file, our Python script, and our input files all in that input directory. But now we see that all of our count files have been automatically saved back to this output directory. The same with our log files being saved to the log folder, and then our standard error and our standard out files being saved to error out. So this is what we should expect to see as soon as our jobs are completed. And I can actually, oh, great. So my jobs are already done. I can go ahead and type Control-C to stop this live view of the queue. Clear to move my prompt to the top, just to bump a space down. If I type LS, and then to list the contents of my output folder, what I see is that all of my count files have been successfully saved back to my output directory. And just to explore one more location, perhaps our error out directory by listing the contents of that folder, we see that all of our standard error and standard out files have also been successfully saved back to that same location. So this is great. So we went from submitting one job to submitting to submitting 5 jobs, all while maintaining a clean, organized workspace. In our last few minutes, I just want to discuss some additional organizational models that you can use by using initial dir. So as I mentioned before, initial dir sets the submission directory for each job. When you set this, it becomes the base path where output files will be saved to. This is a really great option for people who would like to submit multiple jobs from different directories, or if you want to avoid having to write some some paths within your submit file, as well as a few other great features available when using initial dir. So as an example, if we want to return output automatically to a specific directory with initial dir, we could have a setup like this. In our submit file, we would set initial dir equal to some directory name. So in this case, we're calling initial dir equal to a results folder. The important thing is that now that this is the base path, we want to edit the paths within our submit file as needed. So for transfer input files, if we want to transfer our input.txt file, we see that that's already within our results folder, so we don't need to edit the path. However, our shared variables file, which is called sharesvars.txt, is now up a directory. So we want that to be reflected within our submit file so that HTCondor knows where to find the files that you need for your job. When your job is running and completes and your output files are saved back to your access point, your log error and standard error and standard out files will automatically be saved back to that results folder, along with any output.txt file that your analysis creates. Another great use case is to separate jobs based on directory using initial dir. So over on the left, let's say that we have different directories that contain all of the files related to a specific job. What we can do is we can set initial dir to something such as job process ID, or however you end up structuring the name of your folders. What will happen then is HTCondor will automatically go ahead and queue a job for each of these directories. An important thing to note, as Christina mentioned earlier, is that when you're using initial dir, is that your executable should be within the directory with the submit file, so up here, not within the individual job directories. So this is also a really great option for people who maybe have a lot of output files and want them all saved back to the same location. So when thinking about your own analysis, there's a couple of questions that you want to start out with asking yourself. The first are, how big are the files within your input or output data sets? So certain systems may have special locations that they want you to save certain type files. So for example, large files may be saved to one location, small files may be saved to a different location. So you always want to make sure that you're abiding by those rules of your system and taking that into account. Next, you'll want to think about what organizational strategy makes sense for the next steps of your analysis. For example, if you want your inputs in one folder and your outputs in another folder, that could be a great use case for transfer output remaps. Alternatively, if you have many outputs for each job that you'd like to group together, or you want to separate from other job outputs, that would be a great use case for initial dir. Another great use case would be if you want to keep your inputs and outputs for the same job together. That would also be another great case for initial dir. And then lastly, how do you want to organize the HTCondor /system files that are automatically created with your job? These are really important to know where you're going to be saving them to in case you need to learn about your job, for example, publication reasons, or if you need to troubleshoot and you want to be able to quickly find, for example, that standard error file. So with that, I would like to acknowledge the support of the NSF and open the floor to any questions.